doesn't ever stop. All right, so ladies and gentlemen, this example, basically what we have three different values that we need to evaluate for. In this previous example, we only had one function and we had one input. So we were only left to have to plug in that one input in for that one function. However, this function, we have two functions to choose from. We have x squared plus 3 and negative 2x5. And the way that we choose from them is based on their domain. Because we don't have to use implied domain, they give us a constraint on their domain. We can use this function only when our inputs are less than 0. We use this function only when our inputs, our x values, are greater than or equal to 0. So when you look at the first example, it says f of negative 2. Well, I can only plug f of negative 2 in for this function, because the constraint on this one is only x's that are less than 0. So you just plug negative 2 squared plus 3. Negative 2 squared is 4. 4 plus 3 is 7. Done. For the next example, my input is 0. So I have to look at my two domains. This is for all x values that are less than 0. This function is for all values of x that are greater than or equal to 0. So therefore, I'm going to use 0 in this equation, or that function. Negative 2 times 0 is 0 minus 5. And then over here, I have f of 3. Again, f of 3, or 3 is my input, which is obviously greater than 0. So therefore, I'll plug it into the second equation. The biggest mistake that students usually make is they want to plug the values into both of them. Well, the problem is, guys, each of these functions are different for different constraints. So you have to understand that the input is your input has to go to the function of that has that domain that allows that input. So negative 2 times 3 is negative 6. Negative 6 minus 5 is negative 11. OK? So again, guys, that will come back up on that.